In this lesson, we want to look at a third definition for our trigonometric functions. We've already looked at one where our functions were based upon a point, and we found that the sine was equal then to y over r, the cosine was x over r. Then we looked at right triangles, and we defined sine to be the opposite over hypotenuse, and the cosine was the adjacent over the hypotenuse. So we want to look at a third definition that is based upon the unit circle. Now we've already talked about the unit circle, how it's a circle of radius 1, and we're going to look at a point on that circle. So we're going to have a radius of 1, and we have our angle, and we're going to look at a point xy upon our circle. And we have our radius of 1, and this is our angle theta. So our point out here is our point 1, 0. Now we have defined then, if we drop our perpendicular down so that this is y and this is x, then we've defined the sine of theta to be y over r, which is 1, or if we're looking at it as a right triangle, it's the opposite over the hypotenuse, and so it's going to be then equal to 1. The cosine of theta is x over 1, x over r, and in this case r is 1, our radius, which would equal then x. And so what we've done then is we've defined our point up here, our x and our y. Well, our x is actually the cosine of theta, and our y is the sine of theta in this unit circle. And we can then write our ordered pair as the sine and the cosine. Now, let's define this length, this arc length from 1, 0 to this point to be t. As we've looked at radians, we found that our central angle was equal to the arc length over the radius. So in this case, theta is equal to t over the radius, which is 1. So in radians, our angle is t. So the sine of, the cosine of, or excuse me, the sine of theta then is equal to the sine of t, which is y, and the cosine of theta is equal to the cosine of t, if we're dealing in radians, which is equal to x. And so we can define now our trig functions based upon our arc length, upon our t, as the cosine of t is equal to y, the sine of t is equal to x, the tangent of t is equal to y over x, excuse me, y over x, and then the secant of t is equal to 1 over y, the cosecant of t is equal to 1 over x, and the cotangent of t is equal to x over y. Now what we do is we call these our circular functions because they're based upon our unit circle. And we have our functions then for our arc based upon our arc length or upon radians. So now as we travel around our unit circle, our points here are the cosine of theta, the sine of theta, or the cosine of t, sine of t. Let me change that or add that. The cosine of t, sine t, where t is the distance that we've traveled around our circle. And as we deal with that distance, then our points here will be the functions of those. Now, what this is going to lead us to developing is what we call our trig functions based upon the unit circle. So we want to go through and we're going to label these as we go around, and we're going to do it in degrees and radians, and we're going to label the ones that we know by memory. So this point is 1, 0. Most books will have your unit circle in them as to find as we go around. Now I'm going to put some things here. This is 0 degrees. I'm going to put these in degrees and in radians, so it's 0 radians. And then as we go around, we have our values. So at this case, remember this is going to be the cosine of our angle, and this is the sine of our angle. That's what our point gives us. So the sine of 0 is 0. The cosine of 0 is 1. Now these are marked off in units of 15, so we're going to go up here to 30 degrees, which if you remember in radians is pi over 6, which means that would have been the distance that we traveled around. Okay, we know the cosine of 30 is the square root of 3 over 2. The sine of 30 is 1/2. So that would be our cosine of t of that distance and our sine of t. If we go here, this would be 45 degrees, or pi over 4. And we know that the cosine of 45 is square root of 2 over 2. And the sine of 45 is square root of 2 over 2. Our next one would be 60 degrees, which is pi over 3. Well, the cosine of 60 is 1/2. The sine of 60 is square root of 3 over 2. And then if we go to 90 degrees, or pi over 2, okay, our coordinates here, the cosine of 90 is 0, the sine of 90 is 1. We're actually getting our coordinates as we go around. Now the next one we would look at would be the one that would have a reference angle of 60, which is 120 degrees, or this would be 2 pi over 3. And you can see it's the reflection of 60 degrees. And so it's going to have those same coordinates, except we're in the second quadrant. So the cosine would be negative 1/2, and the sine would be square root of 3 over 2. For 135, which is 3 pi over 4, Okay, our cosine would be negative square root of 2 over 2. Our sine would be square root of 2 over 2. And for 150 degrees, which is 5 pi over 6, then our cosine is negative square root of 3 over 2. The sine is 1/2. So that would be our y, which we found as when we made our triangles that those were the ratios that we had. But you can see this is the reflection of 30 degrees. And then we have 180, which is pi, and we know that that's negative 1, 0. Now as we move into the third quadrant, we would have 210 degrees. This is where 30 is our reference angle, which is 7 pi over 6. So our reference angle is 30, but now it's going to be negative, so this would be negative square root of 3 over 2 and negative 1/2. For 225, which is 5 pi over 4, we would have negative square root of 2 over 2, negative square root of 2 over 2. And then 240, which would be 4 pi over 3. Okay, our reference angle is 60, so the cosine would be negative 1/2. The sine would be negative square root of 3 over 2. Then we have 270, which is 3 pi over 2. And in this case, our cosine is 0 and our sine is negative 1. Moving into the fourth quadrant, we would have 300. And that would be 5 pi over 3. Now our reference angle here is 60. We're in the fourth quadrant, so the cosine is positive and the sine is negative. For 315, which is 7 pi over 4. Remember, anytime our reference angle is 45, our denominator is 4. So this is square root of 2 over 2 and negative square root of 2 over 2. And then 330. So our reference angle is 30. And this is 11 pi over 6. So reference angle is 30, so the cosine is square root of 3 over 2, and the sine is negative 1/2. And then we would be back to 2 pi, or 360. And we would start all over. And this is one method that a lot of people use in learning their trigonometric identities, and they're able to see the relationship between the angles that have the same reference angle. So 30 degrees is the same as 150 degrees, but you're in the second quadrant. And so that you can see how your angles are reflections of each other. The same thing, that 30 degrees in the first quadrant to 30 degrees in the fourth quadrant. And that all that's changing is whether they're positive or negative. And so we can actually use the unit circle then to find some values. So as we go around. Now, what if we wanted to find the tangent of 30? Well, we know that tangent is y over x, or we also know that tangent is sine over cosine. So we could find our tangent. It would be 1/2 over square root of 3 over 2. And so that would be 1 over the square root of 3, which we already knew. But you can use your unit circle and find all of your functions. You can also find the reciprocal functions for those. So it is a method that we have of finding all of our functions that are where our reference angle is our special function. And so you need to become familiar then with the unit circle. And we can also do this on the calculator, or we can also, use the unit circle to find certain functions. Maybe we want to know, well, what angles have a sine of square root of 3 over 2? Well, we know that our y value is our square root of 3 over 2, so we can see right here at 60 degrees and going around at 120 degrees. And we can find our values. And in a minute, we're going to do this on the calculator, and I'll show you how to make your unit circle on the calculator and then use your trace function. We also have what we call our odd and even functions. And so I want to look at those. And then we're going to come back to our unit circle here and look at how we know about our odd and our even functions. Functions are considered to be odd or even, which we've looked at earlier and you looked at in algebra, if f of negative x is equal to f of x. If you take your function and you substitute in negative x and you get the same answer as for f of x, then if you remember, we've said that our function is an even function. And we noted that it's symmetrical across the y-axis. So what we're looking at is for positive x, if you get this value, for negative x, you get that same value. It's an even function. Now, if for f of negative x, you get the opposite of f of x, then this is considered to be an odd function. So that's saying when you substitute in a negative x, you get the opposite, you get a negative y. Now what that would look like, if we looked at it on a graph, if we have a point xy, then when we put in that negative x, we get the opposite of y. We get a negative y. And this is symmetrical about the origin. If you remember, we have origin symmetry. And this one was symmetrical, an even function symmetrical about the y-axis. So we want to look at our functions. Let's go back to our unit circle and look at our functions to see if we have odd or even functions. Let's start by looking at the sign. Well, right here, when x is positive, then the y is a positive 1/2. When we go to that same x negative, notice that y is still positive. When the x is negative, the y is still positive. And so we can look then and see if we've got an odd or even function. Let me just change something that I said. What we're needing to actually look at is our theta, the cosine of the angle. The cosine of 7 pi over 6 gives us a positive 1/2 for the sine. We need to look at negative pi over 6, which actually rotates this way. From 0, we would rotate negative pi over 6, which would put us here. And notice in that case, our sign is negative. So when we did the opposite theta, which is our function, what we're substituting in, we got the opposite for the sine. The same thing if we went on around here for the sine of 150, we'll do it in degrees, we get a positive 1/2. If we start back the other way and we do negative 150, which would put us here, we get a negative 1/2. So for our sine, if we wrote this, then the sine of theta is equal to the opposite, or the sine of negative theta is equal to the opposite of the sine of theta. So sine is an odd function. Now, some of the ways that we can use this. If we know that the sine of 30 is equal to 1/2. So that tells us immediately that the sine of negative 30 is equal to negative 1/2. When we put in the opposite sign, the opposite angle, we get the opposite function. If we know that the sine of 60 degrees is square root of 3/2, then we know that the sine of negative 60 degrees is equal to negative square root of 3/2. So we can find then our functions, and if we know one, then we know then for the opposite function. Let's look at one more. And this tells us without looking something up, because those we actually knew by memory. Let's say that the sine of 51 degrees, which we don't know, is equal to decimal 7771. Then if you're asked what the sine of negative 51 degrees is, well, it's simply going to be negative 7771. And so this is how we can use that the sine is an even function. When we get to graphing our functions, we'll also use that concept, that it's an even function, so it's symmetrical about the y. It's an odd function, so it's symmetrical about the origin. Now let's look at the cosine. So if we go up here to 30 degrees, or pi/6, our cosine is square root of 3/2. If we go to negative 30 degrees, then our cosine is square root of 3/2. For the opposite angle, we still got the same value. If we go around to the second quadrant, for 150 degrees, our cosine's negative square root of 3/2. If we go to negative 50 degrees, our cosine's negative square root of 3/2. So our cosine has the same value for both positive theta and negative theta. That means that the cosine is an even function. So the cosine of negative theta is equal to the cosine of positive theta. So if we know that the cosine of 60 degrees is equal to 1/2, then the cosine of negative 60 degrees is equal to 1/2. If we know that the cosine of 5 pi over 6 is equal to negative square root of 3/2, then the cosine of negative 5 pi over 6 is equal to negative square root of 3/2. If we know that the cosine of 62 degrees, or if we're told that, I don't think we would just know that, is 0.4695, then we know that the cosine of negative 62 degrees is equal to 0.4695. All right. Now, let's just quickly, we also know then that they're reciprocal functions. So the secant would also be an even function. The cosecant would also be an odd function. Let's think about tangent. And let's just think here, if we go 30 degrees, the tangent is sine over cosine. So in this case, it would be positive. If we go to negative 30, it's sine over cosine, so it would be negative. Let's go around to the second quadrant. If it's 150 degrees, sine over cosine, which is negative. 210 degrees, sine over cosine, which ends up being positive. So the tangent is also an odd function. And we're not going to go through a lot of the tangents right here, but that lets us know that the tangent is an odd function. And so the tangent of negative theta is equal to the opposite of the tangent of theta. So the tangent of negative 45, we know the tangent of 45 is 1, so the tangent of negative 45 would be negative 1. So we have our odd and our even functions. All right, let's look at our calculator where we can see how to set this up on the calculator, and some of the things are easy to do and some of it's a little different. Now, as we go and we're looking at our calculator, now we know on our calculator that if we've got it in the function mode, we can't graph circles. You have to graph half your circle and then the bottom half, and you can't trace all the way around that circle. But we have a different mode on our calculator that we're going to put in where we can graph the circle, and that's because of our t. So if you go to mode, and we're going to start off in the radian mode, and then we'll also look at this in the degree mode, but go down to function and arrow over to the parametric. And we're going to enter there. This puts us in a different mode so that if we go to, now we're going to do our y equals, notice we get a whole different set of coordinates. We get x sub 1 of t. Well, this is based upon t, and we talked already that our x is the cosine of t. And now when you hit your button where we normally get theta or we get x, we get a t. And if we go down, if you remember, our y is the sine of t. So we're labeling our coordinates based upon our functions. Now let's go in and set our window because we need to do this. Notice it put it as t started at 0 because that's the start of a circle, and went all the way around 2 pi. And we know the circumference of a circle is 2 pi radians. Oh, times our radius, which was 1. And our step here, as we go down, we want to do this one in increments of pi over 12. Now, I'm not sure what this one is, but let's go down there, and all we have to do is put pi divided by 12 and enter. Now, it changed it to a decimal, which was fine, but that means that we're going to look at every 15 degrees. We want 30, but then we want 45, so we need to go every 15 degrees. Now our unit circle has a radius of 1, so we don't need that big of a value. We could go from -1. Let's go from -2 because we need a little margin to +2, and we can go by increments of 1. And then we need to change our y. We'll go -2 to +2. And as you can see, if we graph this, it doesn't look like a circle, so let's do zoom 5, which is your square, and that's going to square it up, and it gives us this nice little circle. Now, what we can do is we can trace as we go around and find our values. And so if we just start tracing, it gives us our x, that's our cosine of 0, and our sine of 0, and it tells us that t is 0. That's the distance that we've gone. Well, as we go around, it's doing it every 15 degrees. So that would be 15 degrees. The next one would be 30. And we know that the sine of 30 is 1/2. This gives us the decimal approximation of 30. The next one would be our 45, or pi over 4. And we can see that our sine and cosine are the same. And so we can go around our unit circle and find our values. So it might be we want, well, when is the sine the same? Well, we saw it, or when is the sine both 1/2? We already saw at 30, which I've forgotten what that was in radians, but here it is again, which is 2.6179939. And we can find out when it's -5. And there's another place. And notice up at the top, it's reminding you what your x and your y are. So at 5.7595. So we can find the places where our functions have specific values, and we can also find what our sine and cosine is. Now we could calculate a value just like we've done before. And maybe we want to know when, for pi over 6, what the value is. So we can put in pi divided by 6. Because we do have these in radians, and so we need to be trying to think radians as we go around. But you can have your unit circle. Now, a lot of times it is easier for us if we have our unit circle in degrees. So to do that, all we need to do is go back to our mode and change it to degrees. Then we can go to our window and go from 0. Now we would go to 360. And we can say every 15 minutes. And it's okay to go ahead and leave our x and y the same, because that was because we squared it up that we would have that. And so let's go back to our function now. Well, I just changed that. Okay, let me go back here. Since I hit something wrong, let me just do this, just zoom 5. Okay, so we've got our unit circle, and we did set up our window from 0 to 360, had a step of 15 degrees. And then this, you can put in any value, but when we went from -2 to +2, but then we hit zoom 5, which squared it up and made our window square. Now we can trace, and we can go around, and we're seeing it in degrees. So there's 15 degrees, 30 degrees, 45, 60, 75, 90, and you can see what your x and y are, and you know that your x is the cosine of the distance of t, and your y is the sine of t. And so you can go back and you can find your values. In a lot of ways, it's a little bit easier when we look at this on our unit circle because we can see pi over 6 and we are having our exact values. When you do it on the calculator, you're not getting your exact values. And so this is a third method that we have then of finding our trigonometric functions based upon the distance that we've traveled from 1, 0 around the circle.